In Chapter 3, we begin talking about different numerical measures that we use in descriptive statistics. In Section 3.1, we look at different measures of central tendency. This is where one number is used to describe the entire sample or population, and it's used to describe where most of the data are centrally located. There are three measures that we'll use: the mode, median, and mean. So in this section, we'd like to calculate the mode, median, and mean. So the mean is one you are probably most familiar with, as it deals with the average. So the way we calculate the mean or the average, some of you already know this. If you were going to calculate the average age of all the students in this class, we would add up all the ages of the students in our class and divide it by how many students there are. That would give us the average age. Now, what's important in statistics is we will use a lot of different notation. So it is important for us to begin to recognize the different symbols and values that we are going to calculate. So I would encourage you to download the PowerPoints from Chapter 3. I'm just going to summarize some of them in this example. So some of the notation in the PowerPoint you will see is lowercase n is used for sample size, capital N is used for population size, and a mathematical symbol we use is this capital sigma sign that we use, which means to sum or to add up. So another way mathematically we represent the mean is for a sample, we use the notation x bar. So this is a lowercase x with a line on top of it, and we call it x bar. Some books will show it as a capital X, but generally it's a lowercase x with a bar, and we say x bar. This is the mean or the average of the sample. In mathematical notation, to sum all the entries, we say the sum of x, and to divide by the number of entries in a sample, we divide by lowercase n. For the population mean, or the average of our population, we use the Greek letter mu. The mathematical formula for that is the sum of x, or to add up all the data values in the population and divide by the population size, which is capital N. So let's go to look at an example. Before we do that, just one more comment about the sample mean and the population mean. In descriptive statistics, we often are describing our sample, so we use the sample mean. When we get to inferential statistics, we use our sample mean with some other formulas to estimate or draw conclusions about our population mean. So one example that we talked about in one of the earlier videos was if we're interested in knowing something about Rhodes State College students, Rhodes State students would be our population, and our sample might be all the students in this class. So if I wanted to know the average age of all Rhodes State students, that would be the population mean. I would need to ask every student, add them up, and divide by how many Rhodes State students there are, approximately 3,000. If I wanted to calculate the sample mean, I would ask you all your age, add those up, and divide by the number of students in this class. I believe we have 25. So let's now look at an example. In this example, it says the Stop and Go convenience chain recently selected a random sample of 10 customers. The store monitored the number of times each customer made a purchase at the store over a 2-month period. The following data were collected. So we have a list of data here representing 10 customers. Customer 1 made 10 purchases over a 10-month period, or I'm sorry, a 2-month period. Customer 2, 19, etc. So let's calculate the three measures of central tendency. Since we're dealing with a sample for the mean, we are looking for x bar. So we want to add up all of our numbers, the sum of x, and then we're going to divide by our sample size. So we will have x bar equals, after we add up all our numbers, we're going to divide by 10. Now, if you remember from the video from chapter 2, we can put this data into our calculator. Do you remember our favorite button? It is Stat. And to look at the data, we go to Edit, hit Enter. Now this was the data of the distance driven to school. So I'm going to clear it out. Do you remember how to clear it out? We arrow up so our cursor's over L1 and we hit Clear and then Enter. Don't hit Delete, it will delete your column. Hit Clear, Enter. Okay, now I'm going to type in the data. So I type in 10 and hit Enter. And 19, I'm going to let you all enter this as well. Enter. 17, enter. 19, enter. 12, enter. 7, enter. 22, enter. 15, enter. 16, enter. And 13, enter. And we have all of our data in the calculator. Okay, so we can do several things here. The calculator actually will give us the mean directly. But before we do that, if I ask you to show your work in the formula, the calculator will also add up all the numbers in this list. Practice doing this will help us when we get to Chapter 5, Discrete Distributions. So anytime we want to do any mathematical calculations on our lists, we are going to go to, if you look above the Stat button, it says List. So first, let's do second quit. You always want to get out of your list when you calculate anything, otherwise it will store it within the list. I'm going to do second list, which is above the Stat key. So I do second because it's in blue. This just lists the name of the list. I'm going to arrow over to the right. You can see some operations we can do on the list. This is another way we can sort things. But I'm going to go over to Math because there's lots of cool things in the Math button here. So if we can get our data in a list, we can do lots of calculations. And you're going to notice right away that you see mean and median, which are two of the measures of central tendency we're looking for. And yes, you can go there, but first let's go to the Sum button, number 5. Choose Enter. I'm going to tell it L1. Remember the L1 is above the 1 key. Hit Enter. And basically if we had added all our numbers up, we would get 150. 150 divided by 10 gives us a sample mean of 15 purchases. Now, let's go back to second list, over to Math, and go to mean. And hopefully, do second L1, we also get 15. Cool, right? Okay, now the median, we need to put our list in order. What the median is, let's go back up here, it is the middle data value. So I need to put my list in order to find the middle data value. Do you remember how to do that? Yes, I know what you're thinking. If I go to second list over to Math, there is a median. Okay, let's go see what it tells us. Second L1. It tells us the median is 15.5. Let's go into our list, our favorite button, Stat, and let's go ahead and sort our lists. Sort A, I'm going to tell it L1. Now remember, when you're sorting, it will just say done. So we then need to hit Stat, Edit to go back and look at it. Put it in order. Okay, so we have 10 data values. We have to put them in order from smallest to largest to locate the median. For an even number, we have to average the two middle numbers. So if you look right beside the L1, it tells us the position of number 7. That's the smallest number. So I go 1, 2, the second position. That's your position number. 3, 4, 5. That's the 5th position. 16 is in the 6th position. So in order to have 5 numbers below it and 5 numbers above it, we have to average the 5th and 6th position. So the average between 15 and 16, yeah, that's right, is 15.5. The mode then is the number that occurs most frequently. Since I have my numbers in order here, 7, 10, 12, 13, 15, 16, 17, and 19, you can see that 19 occurs twice. That's the only number that occurs twice, making it the mode. So we have our 3 measures of central tendency, 15, 15.5, and 19. This section also discusses what the measures of central tendency that will be most affected by extreme data values. So, looking at my list in order, extreme data values would be if we had a customer that came in and made, instead of making 22 purchases, he made 100. Well, if I change this to 100, which of these measures does it impact? Well, let's find out. Change it to 100. Is it going to impact the mode of 19? Nope, doesn't change it. Is it going to impact the median of 15.5? All I changed was the 22, so my 2 middle numbers are still 15 and 16. Doesn't change it, correct? But look at this one. When we change the 22 to a 100, it changes the sum of x, correct? I go to second list, over to math, sum, L1. My sum now becomes 228 divided by 10, making my mean 22.8. So it changes the mean. This means the measure that is most affected by extreme data values is actually the mean.